respiratory system. To understand the process of breathing, in humans, the main organs responsible for respiration are present in the thoracic cavity. In the thorax region, the rib cage and a dome-shaped fibrous tissue known as the diaphragm are observed. Present within the rib cage are the pleural membranes which enclose the lungs. The right lung is divided into 3 lobes: the right superior, right middle, and the right inferior lobe. The left lung is smaller and has only 2 lobes: the left superior and the left inferior lobe. Both the lungs are associated externally with small tubular bronchi which unite and extend into the trachea. The trachea has incomplete C-shaped rings of cartilage which prevent the tracheal wall from collapsing. The trachea leads into the pharynx, which is connected to the nostrils. As we breathe in air, the oxygen molecules enter the nostrils and travel downwards through the pharynx and trachea to finally reach the bronchi. From each bronchus, oxygen travels into the lungs. Within the lungs, the bronchus divides repeatedly to form bronchioles. Oxygen travels through these bronchioles and reaches the alveoli, each of which is surrounded by a network of capillaries. A section of one alveolus shows the presence of numerous alveolar chambers with pores. Blood containing RBCs is seen flowing through the capillaries. The oxygen molecules from the alveolus diffuse into the capillary and then get absorbed by the bluish-purple RBCs. This causes oxygenation of the RBCs, and a transition in their color from bluish-purple to red is observed. The blood moving into the alveolus contains RBCs and carbon dioxide molecules. These molecules are released into the alveolus. The carbon dioxide collects in the alveolar chamber. And then from the alveolus, it travels through the bronchioles into the bronchus, which finally reaches the trachea and is breathed out through the nostrils. So the process of breathing in air rich in oxygen is called inhalation. After the contraction of muscular diaphragm, the lungs expand and the air rushes in, resulting in the inflation of alveoli. During exhalation, the diaphragm moves up and the lungs contract. Thus, the alveoli deflate, causing the air to be forced out. This exhaled air is rich in carbon dioxide. This process of inhalation and exhalation is known as respiration, which is approximately 20 times per minute. Electronic configuration of elements. According to the Bohr's model, an atom consists of a central part called the nucleus, which contains positively charged protons and electrically neutral neutrons. The number of protons in an atom is called its atomic number and is represented by Z, while the sum of its protons and neutrons is called its mass number, which is represented by A. Besides protons and neutrons, there are negatively charged particles called electrons, which revolve around the nucleus in various shells or orbits. This arrangement of electrons around the nucleus of an atom in various orbits is called its electronic configuration. Please note here that the number of electrons in an atom is always equal to the number of protons, which makes the atom electrically neutral. Every orbit has a certain capacity to accommodate electrons. According to the Bohr-Bury rules, the maximum number of electrons that can be accommodated in a particular orbit is determined by the formula 2n square, where n denotes the orbit number. For the first orbit, n is equal to 1. Therefore, 2n square is equal to 2. Hence, the maximum number of electrons that can be accommodated in the first orbit is 2. Similarly, for the second orbit, n is equal to 2. 2n square equals 8. Hence, the maximum number of electrons that can be accommodated in the second orbit is 8. Although the third orbit can be occupied by maximum of 18 electrons, when 8 electrons are occupied in the third orbit, a certain degree of stability is given to the atom. Hence, the next electron, instead of entering the third orbit, goes into the fourth orbit. For example, the atomic number of potassium is 19. Therefore, there are 19 electrons revolving around the potassium nucleus in the potassium atom. Out of these, 2 electrons enter the first orbit, 8 in the second orbit, and the other 8 enter the third orbit, and the remaining 1 electron, instead of entering the third orbit, enters the fourth orbit. Hence, the electronic configuration of potassium is 2, 8, 8, 1. The electronic configuration of an element also helps us to decide the position of an element in a periodic table. The number of orbits or shells denote the period to which that element belongs. Let's continue with the same example of potassium. Its electronic configuration is 2, 8, 8, 1. This means there are 4 shells in an atom of potassium, and therefore it belongs to the fourth period of the modern periodic table. Similarly, sodium with 3 shells belongs to the third period. Lithium with 2 shells belongs to the second period. Rubidium with 5 shells is placed in the fifth period, and so on. The number of electrons present in the outermost or valence shell of an atom decides the group number of that element. Thus, potassium with 1 valence electron fits into group 1 of the modern periodic table. Magnesium with 2 valence electrons is placed in group 2. Aluminium with 3 valence electrons belongs to group 13, and so on. However, there are a few irregularities shown by some elements in their configurations, such as that for chromium, copper, silver, gold, etc., which we will study in a separate topic. Despite these irregularities seen among the elements, it is possible to predict the position of most of the elements in the periodic table from their configurations and vice versa. Area of a circle. Objectives: to learn the concept of the area of a circle, to learn the formula for finding the area of a circle. We know that carpets are sold according to area, that is per square foot. Flooring is covered based on the area. Thus, for covering a floor or laying turf on a circular piece of garden, we need to calculate the area. It is for such requirements that we need to learn the concept of area of a circle and the formula for calculating the same. Let us consider a circle with center O and radius R. Cut the circle into 4 equal sectors. Arrange the sectors in half the circumference with their vertices up and the sectors in the remaining half circumference with their vertices down. The figure obtained looks like an arrangement of curves. Separate the sectors and rejoin them to form the circle. Now cut the circular region into 8 equal sectors. Arrange the sectors in half the circumference with their vertices up and the sectors in the remaining half circumference with their vertices down. This time the arrangement has curves, but they are smaller in size. Separate the sectors and again rejoin them to form the circle. Now assume that the circle is cut into an infinite number of equal sectors. Arrange the sectors in half the circumference with their vertices up and the sectors in the remaining half circumference with their vertices down. Now we can clearly see that the figure obtained is nearly a rectangle. So we can conclude that as the number of sectors increases, the arrangement appears to be a rectangle. The length of the rectangle is half the circumference of the circle and the breadth of the rectangle is equal to the radius of the circle. As the circle is converted into a rectangle, the area of the circle is equal to the area of the rectangle, or the area of the circle is equal to the length times breadth is equal to pi radius times r is equal to pi times radius square. Area of a circle day and night cycle. Hi, my friends and I are curious to know about the day and night cycle. Don't you want to know why we have the day and night cycle? Come, join us on our trip and explore this wonder of the universe. We will learn that day and night cycle is a natural phenomenon that takes place on the Earth. Planets in the solar system are in constant motion and they revolve around the Sun. All these planets, including the Earth, also rotate on their own respective axis. This rotation results in day and night on the Earth. Check this out. The world time zone map shows that it is daytime on some continents, while it is nighttime on the others. How does this happen? Come, let us look at the position of the Earth with reference to the Sun to understand this phenomenon. The Sun is in a fixed position in the solar system. The Earth, as you know, constantly rotates on its own axis, which is an imaginary line that runs from the North Pole to the South Pole through the center of the Earth. This rotation is from west to east and takes 24 hours to complete. Due to this rotation and positioning of the Earth and the Sun, it so happens that only one part of the Earth can face the Sun at any given time. Hence, the part that faces the Sun has day, while it is night on the other side of Earth that is facing away from the Sun. Thus, The rotation of the Earth changes day into night and night into day again. However, that part of the Earth which has night time is illuminated by the moon. But the moon does not make its own light. Just as sunlight strikes the surface of the Earth, it does that of the moon as well. The moon reflects this light onto the Earth during night. This explains the day and night cycle.